So hello guys, today we are going to solve a Leetcode question that goes by the name same tree. It is Leetcode today question. Easy question. Okay. So we'll first start by reading the problem statement. What does the problem statement says? Given the roots of two binary trees P and Q, write a function to check if they are same or not. So what you are given is you are basically given the root of two binary trees. This can be some binary tree, this can be some binary tree, and this can be some binary tree. Okay, so you are given the roots of two binary trees. This is the first node of the tree is known as the root node. Is known as the root node. So you are given two root nodes of different binary trees. You have to determine whether these binary trees are same or not. You have to determine whether these binary trees are same or not. Okay, same or not, or not. Okay, same or not. So how they are considering it as same? Two binary trees are considered the same if they are structurally identical and the nodes have the same value. Okay, so you are given two conditions that they should be structurally identical and nodes have same value. Nodes have same value. What does it mean by that? What does it mean by that? Basically, if this is my tree, then if I compare this, if I am given this root node and this root node, okay, so these have the same structure. These have the same structure. There is only one branch in between. There is only one connection between, and the node value is also same. These can be considered as same trees. Same trees. So what can be the solution for this? What can be the solution for this? This is a very easy approach. This is very easy, following very easy approach. Okay. What I can simply do is, okay, I can basically go by two approaches. First approach is that is the brute force approach. First approach is I can traverse both the trees. And I can store the pre-order traversal of both the trees in different vectors. Suppose this is vector 1, this is vector 2. I can store the pre-order traversal of both of them. Pre-order traversal of both of them. Okay. Okay, and if there is an empty node, I can store some hash or something. Okay, I can store a hash that will tell me that there is an empty node after this. Okay, so if this vector value coincides with this, like both of these pre-order traversals are same, then I can say that they have identical structure and nodes value are also equal. Nodes value are also equal and equal nodes value. Okay, I can just what I said about this. I can simply traverse these nodes. Okay, I can simply traverse this. I can store this in V1. That is my vector 1. I can store this in V2. I can parallelly traverse both of them. And if they contain the exact same values, that means the tree is identical. I am identifying the null values as hash. Okay, null values as hash. So this can be my brute force solution. What about optimal one? Optimal one is also easy. Optimal solution. Okay, so what can be my optimal solution? Suppose you are given these trees, 1, 2, okay, and this is also one tree. I'm considering both of them to be same at start. Okay, so what I can traverse is my root node is this, root 1 is this, my root 2 is this. So if I tell you, if uh, I told you that the periodic traversal is going to say if it's going to be the same, then they are the same trees. They are the same trees. Okay, but if the periodic traversal is not same, they are not the same trees. So what I can do is I can parallelly pre-order traverse them. Like this would also go to the left node, this would also go at the left node at the same time. Okay, so both of these traversals will be taking place at the same time. At the same time. Okay, I will make this R2 traverse to the left node, then return, then to right node, then return. Okay, so all of these would be occurring, all of this would be occurring simultaneously. Simultaneously. And if at any point, I get to know if at any point, suppose if my tree is like this, 1, 2, 3, and one of my tree is like this, 1, 3, 2. Okay, they're looking like the value is same, but the structure is not same. Structure is not same. So if I start traversing from here, this is my first node that I'm going to traverse. This is my second node I'm going to traverse. So they will find that it has not equal values. It has 2 and where it has 3. So my traversal should stop and I should convey traversal should stop and I should convey that the nodes values are not equal. Nodes value are not equal. Okay. So this is my basic approach. I can basically pre-order traverse them at the same time, pre-order traversal at the same time, and if values not equal, then just return. Then just return. Okay. Then just return and tell the answer as false. Tell the answer as false. Okay. So can the values be not equal? Can the values be the only case? Values be the only case of it returning false? Of it returning false? No, no, because it is said that one is the value and one is the structure. One is the structure. Suppose we have seen the value that if both the nodes are present but the value are different, just return false. Okay, just return false. What about the structure? Structure. Suppose basically one tree is like this, 2, 3, and one tree is like this. 1, 3. Okay, and you are given the root nodes. Given the root nodes. So if I tell you that you have to traverse to the left node, you have to traverse to the left node. There's no left node. There is no left node. Okay. So it has no. So the node value will point to null. This value will point to null. This value will point to null. Okay. So I can make it as a condition. I can make it as a condition that suppose if this node is present, one of the nodes in if in if the node is present in one of the trees and not present in any of the other trees, then also I can return false. Then also I can return false. Basically, if the node is present here but the node is not present here, I can return false. Or or if the node is not present in this tree, not present in this tree, but present in this, okay, so I can return false. So okay, but this would return me every time false, right? What would be my ending condition where my true comes? Where my true comes. So suppose if I am traversing till 1 to 3, 1 to 3, okay, I traverse them at the same time. I traverse them at the same time. So both of them would come at the null position at the same time. Null position at the same time. So in this case, I will simply return. I'll not make the flag false. I'll not make the flag false. I'll just simply return. My flag is initially true. My flag is initially true. This is a global variable. And if any of this condition or this condition or this condition, that is if the value or any of the structure condition value or any of the structure condition fails, I should make my value flag value as false. Flag value as false. Otherwise simply return. Otherwise simply return. Okay. Suppose in this case, if I am taking it 1, 2, 3, and this is 1, 2, 3, I'll just traverse and my answer would be true in this case. I'll traverse to here, here, go back, here, go back, here, go back, here, go back. Okay. So this will be the same. In this case, where one of the node would be present. Okay, so this would make my flag false. If the values is not equal, suppose one is 3, 1 and 1 is 3, that would also be resulting in false. Okay, suppose I write the code for this. Okay, so I would make a helper function that would help me traverse both of the trees at the same time. Both of the trees at the same time. It will be the same as, okay, this is my flag variable that I will set to false if any of the condition fails. If any of the condition fails, and if any condition has failed, just simply return without moving forward. Just simply return without moving forward. This is my helper function. That has P and Q, and I have to return my flag value. So, and I'll traverse to the left node and the right node. Sorry. P's left, Q's left, helper, P is right, Q is right. Okay. So this is my boilerplate, like what I do in pre-order traversal. I just have to add one more conditions. I could add two or three more conditions. One is if both of the nodes are present, and but my piece value, my one node value is not equal to the other node value. So what I'll do is I'll simply make my flag as false and I'll return. After the flag has been made false, so it will return automatically because this is my first condition. If my flag is false, then return. Okay. One can be my condition. If everything goes right, just simply return. Just simply return. Okay, and what one condition can be if one of the nodes is missing, suppose P's node is present and Q's node is missing, so I will simply make flag as false and I will simply return. If I try to run it, accepted. Okay, and I will try to submit. So it has been successfully submitted. Okay, nothing I have done different. I just made a flag variable, and if any of the condition fails, I'll simply move it to false. Okay, these are my ending conditions. If everything, this is my ending condition. If everything goes right, and if one of the condition fails, even if one of the condition fails, I have no need to check again. I'll just simply return from that point. I'll just simply exit. Okay, this condition is for if any one of the node is absent. If any one of the node is absent in one of the trees, then it will make the flag as false and return. This is what is my boilerplate code for pre-order traversal. Okay. This is I'm making a helper function and just calling it. Okay. Okay. So this was about the solution of the question same tree. Okay. I hope you guys like the solution. If you have any doubts, just comment it down below in the comment section. Yeah. Hope you like the solution. If you like the solution, do share, like, and subscribe. Okay. Have a nice day. Bye bye.